All right, let's try option B for 26. We're trying to locate which one of the four options is not equivalent to this original expression, which is log base 4 of 10. So let's look at option B. Notice that the base has been changed to 2. So I'm first going to do change of base, log 10 over log 4. And right now this is base 10. But I can change these as long as I continue to keep the exact same positive value in these places. Generally we'd have a positive integer value here instead of like a decimal. So what I'm going to do right now is I'm going to take it, I'm going to make them into 2. And why? Because option B has a base of 2. Let's see what I can do here. So in this position, I could go, okay, 2 raised to what exponent equals 10? 2 to the first is 2, nope. 2 to the second is 4, nope. 2 to the third is 8, nope. 2 to the fourth is 16. Okay, I don't think I can reduce that. Let's try this one. 2 to the what equals 4? Oh, this would be 2. 2 squared equals 4. That means this bottom part is equivalent to 2. So I have log base 2 of 10 divided by, and we just decided that this is equivalent to 2. This is equivalent to 2. Why? 2 to the what equals 4? 2. Now, when I divide, remember this is the same as 2 over 1. So when I divide, division turns to multiplying, and I take the reciprocal of the back value. This 1/2 is going to be multiplied by the front side, so 1/2 times log base 2 of 10. And then as I condense this, I take the value out front and I turn it into an exponent. So log base 2 of 10 to the 1/2. All of that is correct, but remember any value raised to the 1/2, just like 16 to the 1/2, is the same as the square root of 16. So I'm going to rewrite this as log base 2 and then the square root of 10. And this is equivalent to option B, so I can cancel out B. I know that this is equivalent to this original expression. Okay, let's take a look at option C. There's 2 options left. I've already canceled out A and B. That means that either C or D will not work. Okay, so let's start with the original, log base 4 of 10, and I'm going to use change of base, log 10 over log of 4. Right now these are 10s. They can be changed to any value as long as it remains the same. When I look at option C, I see a base 8. So let's make these base 8. Okay, let's see what we can do. So 8 raised to what equals 10? Well, 8 to the 0 is 8, 8 to the first, sorry, 8 to the 0 is 1, 8 to the first is 8, 8 to the second, 64, I don't know what this is. 8 to the what is 4, 8 to the 0 is 1, 8 to the first is 8, 8 to the second, I don't think I can reduce this in any way. So I believe right now my gut tells me I think C is the answer. I don't think it can be rewritten. But let's try D just to confirm this thought. So let's start with D here. We have log base 4 of 10. This is original. Change of base is log of 10 over log of 4. And notice in option D, we have a base of 16. So let's make both of these a 16. This would be equivalent if I evaluated it on a calculator to what we have up above. Okay, 16 to what equals 10? Well, 16 to the 0 is 1, 16 to the first is 16. Okay, I don't think I can reduce that. Let's try this one. 16 to the what is 4? Oh, I could take the square root. So 16 to the 1/2, or the square root of 16 is 4. That means this portion is equivalent to 1/2. Log base 16 of 10 divided by 1/2. And just like we did in part B, division turns into multiplying, and the value in the back we're going to take the reciprocal of. Now I'm going to rewrite that in front. So 2 over 1 is the same as 2. 2 times log base 16 of 10, and then when we condense it, it becomes an exponent. So log base 16 of 10 squared, and we know 10 squared is the same as 100. This is equivalent to D. So I'm able to cancel out A, B, and D. They're equivalent to the original expression, leaving C as the lone one that is not equivalent to log base 4 of 10.